Welcome to part 2 of the probability models and basic rules of probability video. We have already talked about the probability model and verified that the probability model in our Check Our Understanding is a valid model because each of the probabilities is between 0 and 1, and when you add them together it equals 1. The other things I wanted to make sure you have for your notes is I want you to remember the idea of a complement. In statistics, the complement is the probability of an event not happening. So I have some symbology here for you. So we have the probability of not A, or A complement, equals 1 minus the probability of A. So if all the events together will equal 1, if we subtract off the probability of A, whatever's left over is the probability of not A. All right. We also talked about the idea of mutually exclusive. Mutually exclusive is events that cannot occur together. They do not share an outcome. When you flip a coin, it is heads or it is tails. It's not both of them at the same time. So that's the idea of mutually exclusive. And then we also have the general addition rule for mutually exclusive events. We talked about the word or. It's an inclusive or. It's not a choice between two things, it's the joining of two things. Therefore, it uses addition in its, when you want to find out the probability of an or event, because you're joining the two things together. So now what I'd like you to do is pause the video and try to answer the rest of the questions in the Check Your Understanding all on your own. And I really encourage you just to actually try it. If you have to change some answers or make some corrections, that is okay. That's part of the learning process and it's pretty important. So pause the video now, try the Check Your Understanding, and come back and we'll go through it. All right, let's see how you did in the Check Your Understanding. All right, so part A we already went through together. Part B, explain why the events have one child and have two children are mutually exclusive. You cannot have exactly one child and exactly two children at the same time. Therefore, the events cannot occur together, so they are mutually exclusive. For part C, we want to find the probability that a randomly selected mother has less than two children. So when we look at our probability model, the only thing less than two children is one child. They didn't have 0 children as a choice, so we're just looking at this probability, which is 0.22. Now I do want you to notice I didn't write just 0.22. That's a naked number. I said the probability of one child is 0.22. I gave it some context around it, and that's what I'd like you to do also. Part D, find the probability that a randomly selected mother has one or two children. That's our inclusive two, so we're going to add them together. So I'm showing you some symbology. The probability of 1 plus the probability of 2 equals 0.22 plus 0.41 equals 0.63. I guess you could have also written the probability of 1 or 2 equals, I like to see the addition, but if you didn't show me the addition and you just have that, that would probably be an acceptable response also. And then part E, find the probability that a randomly selected mother does not have 4 or more children. Does not have. Okay, so we're talking about a complement. We're talking about the probability of not 4 children, 4 or more children. So the complement of that would be 1 minus the probability of 4 plus children. So I got 0.87. An alternate method for that, if we come back up here so we can see our probability tables, you really could have just added these three together, everything but the thing we're talking about, and you would have gotten the same answer. Hopefully that was helpful. Let me know if you have any questions. See you in class.